For the astronauts and cosmonauts on the International Space Station's Expedition 41, the main job these days is simple to explain. They are there to conduct scientific experiments and make discoveries.
A real opportunity to do something useful, something helpful for humankind, so that humankind in the future would live better, longer, happier, that they develop, that will be more comfortable.
Although after years of preparing for this flight, the station crew members have also learned that their successes may come as a complete surprise. And that's good.
I think the biggest thing will be almost the accidental discovery. You take these incredible experiments that have a lot of thought and you put them into a microgravity environment and you just really never know what the outcome will be.
The dozens and dozens of science experiments include some that take place on the exterior of the station without the human crew's involvement, such as the alpha magnetic spectrometer, gathering cosmic particles in the search for dark matter and dark energy, or the hyperspectral imager for the coastal oceans, viewing light in hundreds of wavelengths to reveal details about the conditions along the coasts. The experiments conducted inside the station cover a range of scientific disciplines, with a special emphasis on human life sciences.
As to the medical experiments, they are very important because humanity is striving to explore space and conquer other planets. This is why we need to understand what we need to do to protect future astronauts and cosmonauts.
These experiments are designed to learn how human bodies respond to being in weightlessness, in order to develop ways to counter the negative effects of that exposure, so future space explorers can be kept healthy and able to do their jobs. But human life sciences isn't the whole of the station's scientific agenda.
Some physics or chemical experiments that we run, maybe for creating some solid substances of the future, or something to develop medical treatments that is of a huge advantage to humankind, and we believe it will benefit the humankind.
We actually fly an electromagnetic levitator, which is an alloy furnace that heats these alloys that we want to look at to several thousand degrees, so they melt, and they don't touch any vessel, any box around them, and that's the way to investigate these alloys.
There is also research into new technologies that would support future exploration, as well as improve life on Earth.
If we are going to send humans to Mars, you'll never know what will break. And if we have a 3D printer where we could just, boom, print out a part, throw it in the machine, fix whatever's broken, this really opens up a whole new dimension of long-range space travels.
The station crew members are also charged with maintaining station systems. That means some routine tasks inside on a daily and weekly basis, but could also mean going outside on spacewalks from time to time. Sarayev and Semikutyayev are scheduled to make such a spacewalk early on in the mission.
In this case, we're going to clean up the outside of the station. Some of the equipment is outdated. We will need to remove it. Some of it will need to be brought inside the station.
That EVA will be supported inside the station by Serova, the first female Russian cosmonaut to fly since Elena Kondakova in 1997. And the first to serve as a resident crew member on this space station. Not that that was her goal.
I never thought about it too much because space is what I do for work. And that's what I think about it. It's my work. But obviously, for Russian women, it might be a breakthrough in this area.
The crew complement changes in November when Sarayev, Wiseman, and Gerst depart for Earth, leaving Wilmore as station commander for Expedition 42. 2 weeks later, he'll welcome 3 new crewmates: NASA's Terry Virts, cosmonaut Anton Shkaplerov of Roscosmos, and European Space Agency astronaut Samantha Cristoforetti of Italy, Europe's first female station crew member, and ESA's representative on hand when the last of its automated transfer vehicles undocks from the station in January. Early next year, Wilmore and Virts are slated for spacewalks that are designed to literally lay some of the groundwork for new docking adapters that will be installed later to accommodate future commercial crew vehicles from the United States.
The power cables and systems that were designed for the shuttle system are not the same for these docking adapters. So eventually these docking adapters go on, but when they get there, they got to have power. So Terry Virts and I right now are scheduled to run some cables. We're the cable guys.
The work by the Expedition 41 and 42 crews is yet another step down the road to the day when men and women from Earth will leave this planet to find out what's out there.
If we work all together, we can build not only the International Space Station, but we can explore other planets. If we work together, if we cooperate as partners, it would enable us to achieve much more.
It's just a testament to what we can do as people when we're given the opportunity with a common goal, and we set our differences aside, and we work for that common goal to do things for the betterment of mankind. And to be involved in that is inspiring to me.